Today on Capechi's Corner, we're going to look at inequalities for two triangles. Our first theorem today is called Sas Inequality Theorem. Now, we have previously looked at congruency, and today we're going to look at inequalities. So let's look at the written part of it, and we'll go back and talk about the diagram. It says, if two sides of one triangle are congruent to two sides of another triangle. So in the SAS, both S's are congruent, but the included angle of the first triangle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Now I know that's really wordy, so let's just take a look at the diagram. So with SAS Inequality Theorem, again, we're not looking at congruency. The sides are congruent, so AB is congruent to segment DE, and segment AC is congruent to segment DF. Now, instead of the angle being congruent, we do have an inequality. So if I say that the measure of angle A is bigger than the measure of angle D, then what I'm saying is this piece segment BC is greater than EF. So that's what the SAS inequality theorem is. The sides are congruent, but one of the angles is bigger than the other angle. So in the triangle that has the bigger angle, that side opposite that angle is going to be bigger than the side that matches up in the second triangle. Now we have a similar idea in side inequality theorem. So the wording says if two sides of one triangle are congruent to two sides of another triangle, so that's the same as SAS inequality theorem. Two of the sides are congruent, but the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second. So for instance, let's look at our diagram. If I'm given that AB and DE, if these segments are congruent, and segment BC is also congruent to segment EF, I also know that segment AC, you can see by the diagram that AC is 10 and DE is 8. So AC is definitely bigger than segment DF. Then I conclude that this angle here, angle B, is going to be bigger than angle E. Now, when I'm working with these diagrams, figuring things out, I a lot of times do what I just did. Whatever angle is bigger, I make it darker and a little bit bolder. So although I know angle B and angle E, I know they're not congruent, but I do have them marked with each having one hump because they're the ones that I'm comparing. I made the measure of angle B I know is greater than the measure of angle E, so I made that little marking a little bit darker. So I know that that angle is larger. Now we're going to compare some triangles and figure out what we know from the markings that they give us. So in number 1, I have segment AC is congruent to segment DF, and I have segment AB is congruent to segment DE. And now I also know that 15, that one side, segment CB, is greater than 14, segment FE. So what I can conclude is the measure of angle A is greater than the measure of angle D, and that is because the side inequality theorem. I have two sides that are congruent. That side's congruent, this side's congruent, and the third side, that's where my inequality comes in, and that's why, therefore, I can say that the measure of angle A is greater than the measure of angle D. Let's look at number 2. Now again, I have markings. I have segment JL is congruent to segment NP, and segment LK is congruent to segment PO. Now again, I have an angle in between. I have 40 and 41. 41 is definitely bigger than 40, so that I can say segment NO is greater than segment JK, and I can say that because of side inequality theorem. My sides are congruent, so again I have one side there that's congruent, and then I have another piece over here that's congruent, and in between those I have angles that are not congruent. There's an inequality there, which is why I can state that segment NO, because it's opposite the larger angle, is greater than segment JK. Let's look at some more examples. So these examples say complete the statements with greater than, less than, or equal to. So in number 1, let's take a look at the diagrams we have. So we know that 12, that matches up. There's some congruency. And I also know that there's a reflexive piece in there as well. Now on my left-hand triangle, I do have some markings. I have 48 and 40, so that I know this angle right in here is going to be 92. And again, because I have a straight angle there, I know this other side's going to be 88. That's really about all I know right now. So let's just take a look and see what else I can figure out. So in part A, it's asking you to compare xy to xz. Now, across from xy is 92 degrees. Across from xz is 88 degrees. 92 is definitely greater than 88, so that would mean segment xy is greater than segment xz. Now let's take a look at part B there. I'm looking at xw, which is that reflexive piece in the center, and I'm trying to compare it to 12. So again, let's take a look at our left-hand triangle there, and xw is across from the angle measurement of 48, and 12, this segment at the bottom, that's the measurement of YW. That's across from the angle of 40. Now 48 is definitely greater than 40, so that means XY has to be greater than YW, which has a measurement of 12. So XY is greater than 12. Now we used two different methods. In part A, we were comparing triangles, and because I had two pairs of sides that were the same, that were congruent, and I'm comparing angles that are not congruent, I used side angle side inequality theorem. In part B, I really was just concentrating on this left-hand side triangle. So that's what we found out about theorems, and just using one triangle, comparing angles and sides. The larger angle is always across from a larger side, and smaller angles are across from smaller sides. And looking at the diagram in number 2, I have two sides have a measurement of 9. And right here I have a 90-degree angle. And I know over here I have to also have a 90-degree angle as well, since I need to have a straight angle is worth 180. So let's take a look. If that one part of that angle is 46, I know this piece right here has to be 44. Now again, I have a congruent piece here. My segments are congruent. I have another side that's congruent as well. And now comparing my angles. So I'm also going to use side angle side inequality theorem in this one, because I have two sides that are congruent and angles that are not congruent. There's an inequality there. So 46 is the larger angle. So B is going to be greater than A. Definitely going to be longer. So in completing my inequality statement, I'm going to say A is less than B, because the angle across from A, 44, is less than the angle across from B, which is 46. Let's take a look at our last few examples for today. Again, we're completing the statement with greater than, less than, or equal to, like we were in the last examples. So in number 3, my first triangle on the left, I have an equilateral triangle. So they're all going to have a measure of 60. Now my right-hand triangle, I have two sides are congruent. This side right here in the center and this side. So I know I have an isosceles triangle. So my base angles are going to be congruent. So I know that one of the angles is already 58, so if I subtract that from 180 and divide it by 2, I know these measures right here are 61. So in comparing C to the measurement of 10, I need to just concentrate on this right-hand side triangle. So I know that 10 is across from my 61 degrees, and C is across from 58, so 61 is definitely greater than 58. So that I know as 10 is going to be the longer side. So I'm going to say that C is less than 10. In number 4, again, I have a diagram that's marked. And I know here I have, let's compare a couple pieces. I have 10 is obviously congruent to 10. And there's my congruent reflexive piece in the center. So I have two sides that are congruent. So now I'm comparing the measure of angle 1 and the measure of angle 2. The measure of angle 1 is across from the longer side 6. So because of side, side, side inequality theorem, I can say that measure of angle 1 is greater than the measure of angle 2, because 6 is a length and that one's greater than 5. So the measure of angle 1 is greater than the measure of angle 2.